Hi, this is Dr. O'Connor. Welcome to Pathways to Chemistry. Here we're told to find the pH of a buffer that contains 0.45 molar formic acid and 0.62 molar sodium formate. And we're also given the pKa here. Let's first write out equation here. So we have the formic acid and in water. Okay, and we have then the formate ion plus hydronium ion. So I'm going to set up an ICE table. So initially we have 0.45 molar formic acid, and we have 0.62 molar formate ion, and approximately 0 hydronium ion. We neglect the autoionization of water, and so this is going to decrease by some amount x, and at equilibrium we'll have 0.45 minus x. This is going to increase by some amount x, so at equilibrium we'll have 0.62 plus x, and then this will increase by some amount x, and we just have x. So let's go ahead and determine Ka, and Ka is going to be equal to 10 to the negative 3.74, and that gives us 1.8 times 10 to the negative 4. And of course, our expression for Ka is concentration of formate ion times the hydronium ion concentration, all divided by the concentration of formic acid at equilibrium. So let's see, what we have then is, we have Ka is 1.8 times 10 to the negative 4, and that's equal to 0.62 plus x times x, and that's all over 0.45 minus x. So we're going to assume that x is very small and that it can be neglected. So let me go ahead and write that down over here. So we're going to assume that 0.62 plus x is approximately 0.62. So in other words, that small concentration change is not going to affect the initial concentration. And then the same for the concentration of the acid. And then we'll check our assumption after we determine x. But what's nice here is our expression here now becomes 1.8 times 10 to the negative 4 is equal to 0.62 times x over 0.45. So now we can easily solve for x. Okay, so what we have then is x is going to be equal to 1.8 times 10 to the negative 4 times 0.45 divided by 0.62, and that gives us 1.3 times 10 to the negative 4 molar. Okay, and x, of course, is our hydronium ion concentration. I'm going to go ahead and check the assumption using the 5% rule. So I just go ahead and take x, 1.3 times 10 to the negative 4, divide that by the initial concentration of the formate ion, and multiply by 100. And hopefully that's less than 5%. If not, we'll have to do the quadratic formula. And in this case, we're lucky. That is just 0.02%. So let's check the other one. 1.3 times 10 to the negative 4, and then the initial concentration of the acid was 0.45 multiplied by 100, and we get 0.03%. 0.03%. So our assumption then was justified. So we can go ahead now and calculate the pH. And the pH is going to be the negative log of the hydronium ion concentration, and that is the negative log of 1.3 times 10 to the negative 4, and that gives us a pH of 3.89. Now, in the next video, I'm going to show you how to do the same problem using the Henderson-Hasselbalch equation.